Okay.
It's
So
it's not.
good evening to all of you, and I'm very happy that Gopal Ji has talked to me to deliver one of the lecture. And being a teacher, till I want to be a teacher, and Dr. Poonam, no, she has introduced me with a very long introductions. If she would have said that I'm teaching from 1982 until I'm interested to teach, that is more than enough introduction for me. So now, looking as it is mentioned that in this particular lecture, we are more interested in the discussion. So, any participants, if you have any questions, no, you can ask me without any hesitations, because even a bioremediations, that word is very small, but the topic is very wide topic. I am not able to cover all the aspects of a bioremediations of a metallic pollutants, and that is why I have selected a microbial remediation of metallic pollutants from a aquatic waste. So I am touching only the liquid waste where we will find various types of a metallic pollutants. Now, to give what I'm going to talk during this nearly 50 minutes. So, first of all, I will give the introduction of a topic. Those who are not familiar with a bioremediation of a metallic pollutants,
Dr.
and
Dave, the screen
uh,
is not visible.
screen is not
Sir,
visible.
the screen is visible, clearly visible. Please check your internet, or you can go to the people and then click on the presentation. Select the way maybe two. You will see one is presentation and one is so two select the way you will see. So you can click on that presentation. Then you might see. It's visible, clearly visible.
So,
I see.
any other
One minute.
any other participants? No, it is visible to all the participants.
Yes, sir, it is
Yes,
visible.
sir.
Okay, okay. So, no, then I will talk about the what are the sources of heavy metals, because when we want to remove it, first of all we should know the what are the sources, and if the metals are very useful in terms of any furniture we are having and the other equipments we are having, but as far as the living being is concerned, now either all the metals or the concentration of metals, they are very useful to us, or if, when they are useful to us, up to what concentration, or if they are not useful, then what is the toxicity of this heavy metal, starting from viruses to animal as big as elephant, no, how even the tree or small plants also, how these heavy metals are toxic. Then we'll come to the remediation process. What are the microorganisms which are involved in the remediation of a heavy metals? Then we'll discuss some aspects of a
No,
mechanism of
sir,
a
not
heavy.
visible.
It's
So,
visible now, sir.
No, sir, no. I'll log out and log in again.
So just go to the people. Are you able to see all the people, name of the people?
Yes, yes.
So there are two Shailesh Dave, sir.
Correct.
So one,
Yes.
so you click pin there in presentation, then you
In
might
the,
see
okay, in the first one where I can
where
hear
there
it.
is presentation, Shailesh Dave
Yes.
presentation,
Yeah, pin to screen.
pin to a screen.
Yes.
Is it visible now?
No, no. Somewhere
Then
something is. Yeah, no. I can hear you, but I cannot.
okay. So there may be internet problem or something else.
Okay.
okay, so
Yes, please
no,
continue, sir.
Yes, yes.
we'll
Thank you.
discuss the some aspects of the mechanisms. Then, after the absorptions or the remediations or accumulation of metal ions, if we want to use the same biomass again and again, then it is very necessary to dissolve the metal ions. Then, what are the biosubstance process feasibility? And if we want, anybody wants to develop any business, so what are the entrepreneurships and the carry home message? So my these first slides, now it may be surprising now why I asked in the title of the slides, no question marks. I think when we want to talk about the metal toxicity, I hope that all the participants know they may be familiar. why the metal toxicity has come so much interesting to the scientists and the society. So it is started in the itai disease, where it is related to the cadmium mass disease due to the cadmium pollutions, and it is started in Japan. And till 1972, there was no much work has been done how to get rid of the itai disease. But then after the 1972, now they have started, and in 2012, almost they were able to remediate the contaminated river, which is flowing the Japan, and that is due to the mining company, those who are doing the mining of cadmium, Mitusi, Jifu, and Toma. Now, these are the company. Another word which is also very much familiar to all of us, Minamata disease, that is also unfortunately occur in the Japan, and it has first time detected in 1956, and people have tried to get rid of this. This Minamata disease also referred as a pink disease because those who are suffering, their skin become pale or pink. And in case of the animals, no, it is also referring as a dancing cow disease, no, due to the effects of this. So with this, that two metal ions, the cadmium and mercury, how the people have suffered. And it is not only the two metal ions which are toxic to us. Heavy metal pollution is a problem for a worldwide concern. We can say the global problems, and the metallic pollutant is also becoming a global problem. And nowadays, due to the electronic waste, it is no alarming situations throughout the world. People are having no enormous number of the electronic equipments, and we know that how we are using the mobile phone. And present generations, they discard their mobile phone within 2 years, which leads to many metal ions. The major metals and metalloids which are occurring in the environment, which the long list is there, but out of this long list, at least we can have the very toxic metal, that is mercury, copper, cadmium, chromium, selenium, arsenic, and lead. This arsenic is not a metal, it is metalloids, which is in between the metal and non-metal forms. But these are the metal ions, which are metals and metalloids, which are present in the, we can say, almost they are ubiquitous. Now, looking to the path of these metallic pollutions. So the metal ions, now geosphere, hydrosphere, and biosphere. Almost all you must be knowing. Now these are the three particular environments. So metal ion, when they are present in a geosphere, that is in a soil, mostly they are in a stable form. They are immobilized form. So metal ion there, their toxicity is there, but they may not be easily available to the living being. So bioavailability of this metal ion is less due to they are binding with soil particle, they are binding with other organic matter which is present in the soil, or they are present in a complex form. Then metal ion from a geosphere, when it comes in a soluble form, it will come into the hydrosphere. Then metal become mobile, and when it become mobile, normally microorganisms, plants, and when we take this metal, we take the water, we take the food along with that mobile metal ions which are present as a pollutants, we take in our body, and they will form. Then from geosphere, it will come to the hydrosphere. Then from hydrosphere, it will come to the biosphere. And biosphere become highly toxic because they are in a gaseous form. So they can travel from one place to other place very easily. And during the breathing, you can inhale these metal ions, and you will find that disease. So this will give you the further idea regarding the heavy metal interactions in the environment. Here, now you can see that now this three upper line, 1, 2, and 3. Now they are the main source of a metal presence. Natural sources, industry and the fertilizers, and fossil fuels. Now, from these three sources, metal ion will come, and they will come through the sedimentations, water and air. So they are the vehicle. These three are the vehicle, and fourth vehicle is the sway. And this accumulator, which is shown in a triangular, now they are the accumulators. So sediments and soil, they are the accumulators of heavy metal ions. Either they are coming from a natural source, they are coming from industry, or they are coming from a fossil fuel. And from these accumulators, it will come to the aquatic plant, it may come to the land plants, it will come to the aquatic animals, and it will come to the large animals. And from all these sources, now if you look to the various arrow, that indicates how ultimately, directly or indirectly, the metal ion, they will come to the human being, our body, and they are toxic to us. So due to this, we are very much interested to get remediations of this metal ion. As in the beginning, I told you that metal pollutions, no, they may be present in a solid state or they may be present in a liquid state. So only today I am covering about the how metal ions which are present in a liquid state, or they are present in a water, or they are solubles, and from that how we can remove the metals. So in case of the solid waste, it is sludge. Those who are familiar with bioleaching, then they know the tailings and ore, lean grade ore, fly ash, and electronic waste. Now these are the very rich sources. These are the very rich sources of a metal ions. And when we are processing any of this, then metal ion gets liberated. They can immobilize to mobilized form. From immobilized form to they will get to the mobilized form, and they will come to the liquid waste. So main source of a liquid which is responsible for the metal ion pollutions, which is mine water, because tailings, lean grade ores, and even the mining activity, which leads to the addition of metal and which contaminates surface water and groundwater. So once it is contaminate surface water and groundwater, either through the food or either through the drinking waters, now it will come to the human being. So this gives now why which are the industry now some of the natural sources, but artificial industrial sources which are responsible for the metallic pollutions. And in the first column, you will find the list of the metals such as Ag, silver, arsenic, barium, cadmium, chromium, mercury, nickel, lead, uranium, millennium. And if you look to the type of the industry, you will get surprised and you also get frightened that you name any industry and they are polluting one or the other metals. Now, industry like photography, jewelry, all we are like to wear the jewelry, even glass, which is used in almost everywhere. And while manufacturing the glass, also the silver will be contaminating. Pulp industry, pesticides, fluorescents, alloy, ink, mining, alloy, and you can look to this list. Forget about the industrial things. Now, I am not against the drink, to make you afraid of taking the juice or anything. Of course, no, they are much better as compared to the aerated drinks. But when you are consuming either herbal products or you are drinking a juice like a carrot, grapes, orange, and many things, or if you are using some herbs, jatamasis or dried grapes as resins, then you will find now. And this is not only limited to this type of the juice or this type of the herbal medicines, but no, these are the reported medicines and the juice where they have found concentrations of metal ions which is beyond the permissible limit. And even if you take this, then definitely now it will go in your body and it will. So other sources. Now, why I am giving the extensive list of sources? No, then you will find that how these various sources are polluting. Here also, The main source is lead-based batteries, then electronic waste, then crowded plumbings and mass buttings, steel and pulp industry. And here you'll find the list of the part of the body which are affected. Will not go into the detail. And such a small concentration of this metal ion, when it is present, they may found toxic. Now, just to give you the overall idea, arsenic will affect skin and nasal spectrum, cancer and jaundice. So here, what I want to focus is, the effect will be as mild as nausea or as mild as headache and as severe or as dangerous as the cancer. So depending upon the type of the metal, depending upon the concentration of the metals, through which organism, which path which is coming in your body, and how long your body is exposed to any of these metals, then you will find what types of the disease or the health problem you will come across. So now we'll come to the, with this background, that when we say that there are so many sources of metal contaminations are there, so many industry are there, and they are playing very significant role in terms of our health. So definitely people must have thought about the process for metal remediations. And yes, physicochemical process for metal remediations people have tried since century. Now we will not go into the more detail about the physicochemical process. Many of these physicochemical process are used by microorganisms as a biological process, and they would be useful as compared to this. So in case of physical chemical process, foam separations, chemical precipitations, reduction of the metal ion, absorptions, reverse osmosis. Now almost all you are familiar with the reverse osmosis because RO water we are using, chelations, cementations. Those who are familiar with the mining, they will know because cementation is ultrafiltrations. Once again, drinking water, we are having the RO system, you are having the ultrafiltrations, electrodialysis, electrodepositions, ion exchange, xanthine process, and evaporation. Now, these are the basic chemical processes are used. But these chemical processes, they are having their own drawbacks, such as any of this process, their efficiency of the metal ion removal is very low. And particularly when the metal contaminated water or metal contaminated liquid is having the low concentration of metal ion, then this chemical or physicochemical or electrochemical methods are not very effective. The second thing, high energy or the reagent required. So they are cost intensive. Now, the main problem of any industry, now those who are working in the industry in a wastewater treatment, now industry is not ready to pay a single paisa for any development in the wastewater treatment because it is not giving any benefit to them. They are not earning money out of this. So this process are high energy and the reagent requirements, need for a expensive equipments. We know that normally when the villages and nowadays also in the villages, people drink water with only the earthen pot and they are not much suffering. And in the city, we have to use RO system. So expensive, it may cost 20,000 or more than 20,000 and running cost, you have to use electricity, then you have to change the membrane and all these things. Process are tedious and time consuming. And the very more significant things or very things which all of us we are curious is, they are developing secondary pollutants or side effects, or we can say the byproduct which are toxic. Because in case of any of this method, either you have to use electricity or you have to use chemicals. And when you are using electricity and chemicals, no, the sludge is produced, the chemical sludge is produced, that itself is toxic. So it means you are just converting a liquid waste to a solid waste. Then once again you have to go for the treatment of the solid waste. So when these types of the drawbacks are there, people have thought normally it happens not only in this process, in most of the process, when physical methods are not feasible, no, they will approach to a chemist and people will try to a chemical methods. When it is not possible, then it is electrowinning or some other methods. When none of these methods are beneficial or none of these methods are reaching to their target, that at last, no, they will approach or they will think about the biological methods. So in case of biological methods, or what is bioremediations? Bioremediation is an approach used to either eliminate and turn the contaminant from heavily toxic or highly toxic or more toxic to a less toxic substance. So remediation, bioremediations by microorganisms or plants or animal products. It is any type of the pollutants. This I have given the generalized definitions for bioremediations. So any pollutant, any toxic compound, either you can degrade it, you can remove it, or you can transfer it to a non-toxic or less toxic compound. Then it is known as a bioremediation by using microorganisms or biology. The pollutant includes, such as in case of this metalloids, heavy metals, oil, hydrocarbon, pesticides, dyes, and the list will go from hundreds of the pollutants where microorganisms or plants or the plant products are used for their degradations. But in case of metal ions, metal pollutants, they are non-biodegradable. Once you release or once the metal ion is present as a pollutant, either you have to remove it or you have to detoxify it. They cannot be degraded. No, the half-life of these metallic pollutants are years together. Toxic metal ions or metalloids and the biotic and abiotic pollutants are eliminated using the nano-sized particles synthesized from biological material like bacteria, fungi, algae, and plants. So here, no, with these definitions, if we try to understand bioremediation solid, that what I told you, I'm not going to discuss anything which is equally having the same detail, and liquid. So biosorptions, bioprecipitations, biocomplexations, bioaccumulations, biotransformations. No, these are some of the mechanism or some of the process by which metallic pollutants are removed by biological material. So here, from a liquid waste by the metabolic dependent or independent mechanisms. So if we go, so any of this process, then mainly these bio remediations of a metallic pollutants, they will be divided in a two main group. One is a metabolic dependent, another is metabolic independent. Those processes which are metabolically independent, they are the passive processes. Those which are metabolically dependent, they are the active process. When you are using a metabolically independent mechanisms, you can use live cells or dead cells. But when you want to apply the metabolically dependent mechanisms for the metal removal, you have to use only and only the live cells. And then due to the metabolic activity, they will do either transformations or the detoxifications or sequenciations or many more other forms where the metal ion become immobilized or less pollutants. So once again, now extracellular accumulations, how this metal can be removed from water. So we'll go in detail afterwards. the extracellular accumulations. So it is outside the cell, outside the cell membrane, either it is in the cell wall or outside the cell wall. Extracellular precipitations. That is, microorganisms are secreting something, they are producing something, exudates, and due to this, the metal ion will get precipitated. Extracellular complexations. As I told you, metal ions are toxic, but the toxicity depend upon the bioavailability. So when metal ion, they are in immobilized form, insoluble form, they may not be toxic. So extracellular complexations, that microorganisms and living beings, they produce something outside the cell which complex with a soluble metal ion which is present and make it insoluble. The other one, adsorption on a cell surface, which is very, very fast process. And most of the metal remediations phenomena, they are using all the mechanism, but the mainly the absorption mechanism is preferred and used very extensively because it's a very fast process. Or you can go for the microbial transformations, such as volatilizations, or you can go for the oxidation reduction mechanisms. No, we'll discuss this one by one also. So in case of biosorption, the presence of a numerous functional group. Now, all the metals, no, they are positively charged. So when we talk about the nature, no, we know that the no, nature is taking care of all the type of pollutants, and if anthropogenic activity or the human-made activity are not present, then nature have the solutions for all the types of the pollutions or all the type of the problem. So they have made almost all the microorganisms, they are negatively charged. So metals are positively charged, microorganisms, they are negatively charged, and we know that the positive and negative charge attraction is there. So without doing any activity, if metal ion will come in contact with the microorganisms due to the positive and the negative charge, no, the metal ion will get attracted and it get deposited on the microbial cell wall. So the negative charge on the cell wall or surface of a cell is mainly due to either carboxyl group, amino groups, hydroxyl group, alcoholic group presents, either amines, esters, sulfidyl groups, phosphoryl groups, sulfonate groups, thioester, thioester. If any of this group, they are present in a different concentration on a different organisms. But all these groups, ultimately, they are responsible to provide the negative charge on the microorganism. And due to this, these groups are attractive.
Sir, amino group is positively charged, so how it will attract metal?
Which one? Amines.
Amino group.
Amino group, no, when they will come into the combination, they will give the negative charge.
Okay. Okay.
Generally, the interaction between the pollutants and the surface of the biosolvents can occur through the electrostatic interactions. The other things, only absorptions and electrostatic interactions, aggregations, complexations, coordinations, microprecipitation, ion exchange, reductions, or oxidation. So we have seen the list of a physicochemical methods. These microorganisms, they are having majority of these reactions depending upon the types of enzyme they are having, types of the chemical compound they are having, and their metabolic active. And due to this, you will find the absorptions of metal ions. Now, this metal ions, as we have discussed, extracellular, on cell surface, and intracellular. So, extracellular and on cell surface, normally we will find the metabolically independent, but intracellular, they are metabolically dependent. So, no, it is difficult to give complete list of the mechanisms in detail. So, extracellular, what will happen? Physical entrapments of a precipitated metal in the polymers. As for example, so now if you take the example of azotobacter or rhizobium, they are producing the exopolysaccharides. That the polymer which is produced matrix, they will entrap this metal ion. Then natural polysaccharides which is produced, uronic acids, hexosamines, organically bound phosphate which are present. Now, due to this, metal ion will get attracted, and some of the compound which is produced, which will volatilize. Particularly, this volatilizations is used for the remediation of a mercury. And in case of gram-positive and gram-negative bacteria, those who are knowing microbiology know it's the peptidoglycans and carboxyl group and teichoic acids. In gram-negative bacteria, it is phospholipids. In case of fungi, chitin layer, phosphate, carboxyls, amines, and other groups, they are responsible for the attraction. In case of intracellular, where the transport mechanism play important roles and diffusions. So it is now the semi-permeable membrane is there, but those organisms which want to get resistant to metal ions, no, they will do some characteristical change in a semi-permeable membranes, and this metal ion will get diffused inside. But if it diffuse inside, then it may be toxic. So the compartmentations of this diffuse metal ion will take place in the microbial cell. But for that, metal resistant cell body is required. And this process are energy dependent. Specific metal binding proteins are present and which are responsible for the accumulations of this, such as glycoprotein, lipopolysaccharides, which are present, then methyl lines, glutathiones, these are present and they will bound the metals inside the cells. Now this will give the idea. Here you can find, now this all metal ions are there, all metal ions. So the half part of this shows the gram-negative bacteria, half part with this, to make it combine a gram-positive bacteria. So, and here you can see this is peptidoglycan, then cell wall protein, and this is phospholipids, lipopolysaccharides, and protein. Now, these are the substances which are present in a cell wall, and all this, they are providing the attachment site for the metal ions, and metal ion will go inside, and genetic material, that is the modified material cell, genetically engineered organisms will do this process much faster and accumulate it to a larger quantity of this. Once again, now to give the idea that which organisms and how it is accumulated, we will not go into the detail, but if I take the example, rhizopus, most of us, you are familiar with the rhizopus, uranium and thymium. Now, they will be either removed by cell wall, chitin. In case of bacillus, list of the metals, cell wall and peptidoglycans. Even E. coli, long list of the metal ions, cell wall and peptidoglycans. If you take azotobacter, lead, if you take this one, copper and cadmium, why this? Many organisms, they are having almost similar attractions for most of the metal ions. Whereas some of the organisms, due to their chemical compositions of the cell wall, they are having preference for the selection of the particular metal ions. One of my students, she worked with a Aspergillus terrace. And why? Because in terms of a pollutions, it is all right that you can have the base metals and any toxic metal removal. But if you want to develop a process, not only the environmental point of view, but a commercially viable point of view, then you have to go for the precious metal. So as In one of my slides, I will show you that how many students they have done PhD under me on the metal ions. So one of my students, no, she was interested to a precious metal. So there we have developed Aspergillus terrace, which is having specifically high binding and attraction probability for gold and platinum and palladium. Sorry, gold and palladium. So this field, we can say it is not fully saturated. Now, what is the difference in the cell wall compositions of a Aspergillus terrace? So it is not having the same attractions for copper or zinc or lead and having more absorptions capacity for palladium and gold and silver. Apart from this biotransformations, as I told you, that the metabolically dependent and where you will find the involvement of these organisms. So we will not go into the detail, but the group of these organisms, they are converting uranium 6 to uranium 4, which is less toxic. Chromium 6 to chromium 6, 3, less toxic. Selenium 5 to metal seleniums, less toxic. Lead 2 to lead 0, less toxic. Tellurium 7 to tellurium 4, less toxic. And mercury to mercury 0. This mercury and selenium, now they are the volatile metal and they can, so my other students, she work on the mercury and she has used the bacillus group of organisms and where we were able to remove more than 99.9% of a mercury which is present. And the best thing is, no, this it was get volatile, and we were trapping this volatile mercury pollutants into the alkali, so it can get rid of. Here, nowadays it is the nanotechnology and how the microorganisms are used for the nanoparticle developments. So very vast field is there. Now, gold nanoparticle, then gold nanoparticle, titanium nanoparticle, MgO nanoparticles, and all these nanoparticles, they have the capacity to remove this metal ion, copper metal ion. It is not metal degradation, it is metal sorption or metal transfer. It is not metal degradation. Zinc, copper, chromium, nickel, mercury, and cadmium. No, this list is there. Now, when you want to study, we'll go slightly to a technical point of view. You have to determine how this metal ion are absorbed. Either what is the kinetic reactions, what is the absorption capacity of the used metal ion. For that, you have to study the isotherms. And mainly the Fundius and Legmier isotherms more commonly studied. And depending upon this log K value and 1 upon N K value, it is decided that up to what concentrations your microorganisms or used organisms can remove the metal ions. And we have worked with my other students, he worked with a penicillium biomass, what we have got from the fermentation industry, that I will also talk to you. So not only the microorganisms, but the plant can be also used. And here, this is also a small list of the various biological material which can be used. So plant, and not necessarily only for copper and zinc. This is from the reference I have taken. Then the seaweeds, sewage sludge, because this is also the waste. Then fermentation waste. This at that time, this I'm talking about the 1995 or something. At that time, this field was developing and we were using the fermentation waste. So first I have collected the penicillium mycelium from Alembic, and then Hindustan antibiotics Pimpri. But whatever happened, that we got very good results. Then their waste. Initially they said that yes, you can collect the waste, you can use it. When they came to know that this waste can be used for the removal of metal ion, they say now we will charge 25 rupees per kg, then they ask for 100 rupees kg. No, this waste, we were using the waste. So, but in the fermentation industry, because when you want to use this process at a large scale, you require truckload of the biomass. And if you develop this truckload of biomass as it is in a last row, laboratory grown culture, then it may not be economically feasible. It means if you use as an industrial waste, because most of the industry they are using some of the bacterial cultures or some of the fungal cultures for their production. And once the product is produced, now if they give this waste material, it would be very good source of a metal removal. Once again, we will not going into list of the various types of the bacteria, fungi, algae, immobilized biomass, because now this list may not be only restricted to these organisms. Now we go to the more understanding. So when you are selecting the biomass, then what are the criteria you have to take? Uptake rate. If you are having three different organisms, but uptake rate of the one is low, second is higher, and third one is the highest, then you have to take the last one, which is having the highest uptake rate. Means then your hydraulic retention time for that treatment and solid retention time for this treatment would be minimum. Either it is removing a single metal or multiple metal. That is depending upon your choice. As suppose no that for my student we have collected the goldsmith waste, because if you go to the goldsmith, no, they are taking your ornament, or when they are preparing ornament, they are dipping in some acids. So some of the metal ion will be dissolved there, and that waste is containing a single metal. So under these conditions, you have to use a organisms which are more efficiently working for the desired metal. These multiple metals, when the industrial waste of a many metals or a domestic waste, influence of environmental factors. When you are dealing with metabolically dependent or independent, when it is metabolically dependent, then any factor which affects the growth of microorganism, same factor. Criteria for selections. The biomass should be as cheap as possible as a waste material. That's why we want to use it from the waste, and it should be available round the clock, 365 days. As we have experienced that, as I told you, the fermentation industrial waste, they say now we will not give it to you. So then you have to find out the availability of the biomass. Now, the process feasibility. Raw biomass source. What is the raw biomass source? If you say the seaweeds or some other materials, or if you say the fermentation industrial waste, then that you will get in huge quantity. Then metal uptake performance. So how many cycles the same biomass you are using? With one of our students, he was using 51 cycles. And after 51 cycle also, the absorption capacity of biomass was around 25%. So the biomass granulations and treatment. This is very important when you want to go for large scale productions. The main hindrance in the biosorptions by the microbial biomass, no, they are very soft. And if you prepare a granulations and you have to go for a column or dump or like this type of because you have to treat in terms of a million liter of water. So due to the height, that granules get creased, and permeability and the percolation will affect it. So whenever you prepare a granulations, they should be enough hard. But when you want to go for, no, it is a critical situation. When you become more, you want to make it more hard, then the permeability will go less, and that will also affect. Then the desorptions, because once the biomass is used, how you can dissolve the absorbed metal, and the regenerations. These 2 points we are discussing in the next slides. So criteria for the good desorptions. Why this is, as I told you, in one of my students use it for 51 cycle. It means whatever the process of desorption what we have developed was able to remove the metal ion from the biomass without adversely affecting the biomass. So here the process of a desorptions, that is high concentration metal effluents, undiminishes metal uptake upon reuse. That should be the criteria. Means when we have used this biomass up to 30-40 cycles, that biomass was removing more than 80-90% as compared to the first use. So no physicochemical damage to the biosolvents. So otherwise, the easiest method to remove the metal ions, you can take the concentrated. And that's why we have to calculate the CR ratio. Eluent metal concentration divided by feed metal concentrations, and that ratio depending on this. Now, as I told you, this can be used for the dead biomass also. So when you are using dead biomass, as we know that the metal ion, they are highly toxic. But when you are using dead biomass, the toxicity has no effect on the biomass. Then, in case of the wastewater, industrial waste, there is no nutrients. If you want to use the live biomass, then you have to provide the nutrient, which increase the cost. While you are using the dead biomass, there is no need of the nutrients. Shall I continue for 5-10 minutes?
Yes, sir. Yes, sir. Please continue.
So scarcity of the nutrients, which is a one hurdle for the live biomass. But when you're using the dead biomass, there is no need of providing the nutrients. Then high variations over time. In case of the live biomass, now if you are using an industry, those who are working with the industry know it is not changing every week or every 15 days. Within a day, morning the industrial waste is different, afternoon it may be different, and evening it is different, and night it is different. So you will find high variation in the type of the waste in terms of pH, in terms of the temperature, in terms of a types of metal ion present, in terms of a protein present, in terms of other organic matter present. Under these conditions, live biomass may have the limitations, while dead biomass may not be having the limitation. Maintenance of the live biomass is an impractical way, because no, the conditions which is optimum for the growth of the biomass may not be the optimum condition for the biosorption of the metal ions. So in that conditions, to maintain the live biomass is difficult. Addition of nutrients support growth and activity of the unwanted organism also. When means you cannot have the like a pharmaceutical industry or a sterile process, because you have to treat in terms of a million liter of water, and that to a waste. So when you are using the live biomass for the growth of this, if you add any nutrient, then the other organism will also grow, and that organisms may compete with the what added organism you have developed in your laboratory. So that is the advantage of a dead biomass. Regeneration and reuse of a dead biomass is much more simpler. You can use slightly harsh conditions to dissolve the metal ions as compared to the live biomass. And when you use the harsh conditions, you can dissolve the metal much more faster, and it will affect less to the biomass, so you can use for many more cycles. Competitive as polishing or secondary treatment. As we have said in the beginning, wherever any physicochemical process, no, you cannot replace all the physicochemical process by the biological process. But physicochemical process, they are very good for highly concentrated pollutants. But when the physicochemical process are not able to remove the metallic pollutants below the permissible limit, then either dead or the live biomass, they will work as a polishing and the secondary treatment. Intrinsic rate of the biosorption is rapid as compared to complexations, as compared to the precipitations, as compared to the transformations, and many more things. Excellent biomass which is available in the markets and which are used commercially, they are trade names they are using. It is AMT, BioCleans, Algasops, Biofix, Biomets, and they are in terms of a few thousand liter of a reactors they are using. So the main problem of that the granulations, Now, here also we have used various material to give the granulations, sodium alginate, then the egg cells that we have made, then some other organic chemicals we have used, and whichever find a better that you have to use, so you will get the permeability at the same time the strength of the developed biomass. Now, what type of the entrepreneurships you can get? So, new types of a microbial products you will get. As for examples, see, one of my student, she has worked with bacillus group of organisms, and we have developed process for the remediations of a mercury. And we were using the chemical method for the estimations of the mercury, benzene. So a benzene mercury complex would be formed. And we got one culture which was growing in presence of a benzene, in presence of a mercury, and when mercury benzene complex is present, it was giving very, very high concentrated green color. But when we have developed that, we have added that biomass, now the benzene, the mercury from the benzene was removed, so much so that that benzene we can able to use once again for the estimation of mercury. It means it is non-detectable level. So this is a new type of the microbial product you will develop. Then other students she has used for the manganese, Mn, for the remediation of this metal. One other girl, she has used for the arsenic. And fortunately, we got a two arsenic culture, two arsenic resistant cultures, which were using arsenic as their food. So they are eating that arsenic. And due to this, arsenic is removed. And other cultures, they were transforming arsenic now from more toxic compound to less toxic compound, the arsenic 3 to arsenic 5. Arsenic 3 is 100 times more toxic as compared to arsenic 5. So the oxidation of this. So this depends upon what type of the metal you are dealing with. Assessing the effluent problems. Now, most of the industries, as we have seen that the industry, they are responsible for the metallic pollutions. So any of this industry, they are having metal as a pollutant. So you can go and you can solve this problem. Assessing bioabsorption applicability in their industry, either that can be done or not. Developing a customized treatment in wastewater, it is like a design food or a design dress. Whatever you develop for that industry may not be applicable to the second industry. It means you are having the advantage that nobody can steal your process. If anybody wants to use for the other industry, then he has or she has to do some laboratory research work. So it is developing a customized treatment. So your business will go from industry to industry. At present, no, I am solving some problems of a metal slag industry based in the Indore, and some foreign country also. They have sent some of the ore sample, and we are no. That is the other part from a solid to removal of metal ion from the solid. Designing and building the plants. If anybody wants to use the bioabsorption, bioaccumulations, biotransformation, then they require the plant design. So you can help them. Operating the treatment process. Now, naturally, if the microorganisms are removing, then what is the work of a microbiologist or a biochemist or a chemist? So here we are giving the pre-treatment to the biomass. And when you are giving the pre-treatments, now you are converting many the positively ion part which are present on the cell wall of the bacteria to the negatively charged part. And that increased bioabsorption capacity. Metal recovery. Particularly, this is for precious metal. Now, when you are dealing with a gold and platinum or palladium, and you can recover the metal. At present, I am also advising some persons to, because we have developed process for the gold recovery from electronic waste. So I'm developing this process. Unfortunately, I'm not having the lab facility where I can work with the metal ions again. Then target industry for this was metal plating industry, mine drainage. No, sometime we will talk about the acid mine drainage, which is a global problem. And they are having the two problem, high acidity, and they are having the metallic pollutions. And even if you stop the mining today, as per the available data in 2024, some of the foreign mines which was abandoned before 200 years, please listen to this, which were abandoned before 200 years, still that minings are producing acid mine drainage and metallic pollutants. So no, it is a long lasting process. Then coal fired power generations were also metallic pollutions, and metal processing industry. So I want to just summarize. So bioremediation is the applications of microorganisms or microbial process or a product to remove or degrade contaminations from an area. Now this degradation that is for a organic matter, not for metals. Metal can be transformed to a non-toxic form. A major rigorous definition is bioremediation is the intentional use of a biological degradation process to remove or to reduce the concentration. So here to remove and reduce the concentration of environmental pollutants from the site where they were placed or released. And bioremediation project or a program should consider many aspects of the sites, the contaminations, the microorganisms, the environments, the goal, regulatory limits, regulatory laws, and appropriate agencies by this, and future of would impact the successful outcome of the projects. I would like to thank my guide under whom I was initiated to work with the metal ions, Professor J.V. Bhatt and Professor K. Natarajan. Professor J.V. Bhatt, he is considered as a father of microbiology of India, and he retired from IISc Bangalore. And Professor K. Natarajan, under whom because he is a metallurgist, and at that time I worked with a NIT Surathkal. Then Dr. Natarajan has joined IISc Bangalore in metallurgy department, and he's 85. Still, IISc have the facility that he can go and work. So almost every year, I am going once or twice, and I am spending 1 week or 2 weeks with him in his laboratory, because now I am learner for the metallurgical science, extractive metallurgy and the removal of metallurgy. And the remaining list of the students, those who have worked for metal remediation and metal absorptions. So whatever I have talked to you, it is not only my contributions, and it is the contributions of all my students, and this field which is initiated in my mind by Professor J.V. Bhatt and Professor K. Natarajan. So I am thankful to all of them. And of course, till today I am working with whatever the project I will get. So I got various projects from UGC, GSPTM, DBT, DST, GMDC, and nearly they have funded me more than 5 crore rupees of the projects, where we have developed various processes for bioleaching, biosorptions, bioremediation of metals, and many more processes. So thank you very much for for giving this attention.